So today we're going to talk about how to organize coordinate proof. We're not going to actually do coordinate proof. We'll give you some examples, but actually the session tomorrow, okay, homework tomorrow, you're going to be actually doing coordinate proofs. For today, we're just going to show you how to organize, okay, this coordinate proof. Because once you organize it nicely, okay, it's going to be that much easier for you to do the proof. If you don't organize them the way you should, it's going to be very difficult than it should. All right, so first of all, let's talk about what it is. I sort of talked about this before when we said we're going to do some new way of proving. We're going to show you how to prove in a different way, right? Rather than just direct proof, you know, two columns, or like proof by contradiction and so forth. We're going to do this. We're going to be doing this proof by algebraic proof, right? This is what we're talking about. Coordinate proof. Sometimes it's called algebraic proof because you use a lot of algebra. So let's take a look at this here. How about who wants to read this for us? This part here. How about Michael? Go ahead.
We will illustrate coordinate geometry methods by proving theorem 5 that
Mm-hmm.
the midpoint of the hypotenuse of the right triangle is equidistant from the three vertices.
Yes. So do you guys remember this theorem?
Yes.
This M is equidistant from all three vertices, right? We proved this, but today I'm going to show you how to do this using coordinate proof. Okay? To do a coordinate proof, we have to first use some of these things that we learned. Let me go back a little bit. You know how when we prove for the midterm of a point, or like equations of linear equations, or we did some of these theorems, we proved these theorems, right? Using algebra and so forth. That's what we're going to be doing with these kind of things. Yeah, so in a coordinate proof, as a coordinate proof. So let me show you. First of all, what you have to do in order to do a coordinate proof is you have to think about then how are we going to use this algebra to show that M is equidistant from all three vertices. Anybody see what you could do? How can I do this? Yeah.
Find MR, MP, and MO and see if they're equal.
Yeah, you just figure out the distance of all these three segments, right? MR, MP, and OM. Then you'll be done. If I could show that the distance is same, right? So that's how we're going to use that, you know, those algebra that we learned, those formula. So we just basically have to find the distance of these three segments. Turns out you don't have to find all three because they have given us that M is the midpoint of PR. If you know MR, you know MP also. Does that make sense? So you could find all three distance, but it's not necessary because we know that M is the midpoint. Does that make sense? You get that? Now to find the distance, we need what? We need the coordinates, right? So we need the coordinates of these points, right? Right now, we don't have any coordinates, right? So how are we going to find the coordinates of these points? Can I call this P like 0, 2? Let's call this O, 0, 0. Isn't that the easiest one? So let's call this 2, 0, and then 0, 2. Can I do that? And then find the distance? Why not? Isn't that a right triangle? Why can't I just plug in? Okay, let P be 2, 0. Let R be 0, 2 or something. And find the distance. Nicholas, why can I do this?
Because that's just proving it for that for one set.
Exactly. That will be a proof for that particular example. I want to show it for what, Nicholas?
For
Every single right triangle. Very good. If I say 2, 0, and 0, 1 for this, that doesn't represent, right, every right triangle, does it? That's actually an isosceles right triangle, right? Right? We have to represent a triangle, right triangle, right, in a way that it represents every right triangle. And we want to prove that, right? We want to use those. So how are we going to do this? We have to use what? Yeah, instead of numbers, we have to use some variables. Okay, so why don't you read this for us? How about, Dylan, can you read this for us? Let OP. Hmm? Okay, and we're going to, of course, to make it simple as possible, let OP be on the x-axis and OR on the y-axis. And here is the way they label these points. And this is the kind of work that you're going to be doing tonight. Okay? And we'll show you how, okay, we do this in a way that's helpful for us. Does that make sense? So look at what they did. Look, they just chose M as A comma B. That's what they did. Okay? Because M, we don't know what the order pair is, do you? Right? But if M, since M is the midpoint, you could actually figure out that P is 2A comma 0 and R is 0 comma 2B. Why? should be like this. If M is A comma B, right, some unknown point on this hypotenuse of this right triangle, why should point P be 2A comma 0 and then R be 0 comma 2B? I want you to think as a group. How did they get that? Okay, think about it. Where did they get? How did they come up with it? How did they come up with that? Okay. So, who's got this? Jonathan? What do you guys? What did your group come up with? How is it that they say P has to be 2A comma 0 and R has to be 0 comma 2B?
If you plug in the
R
coordinate
and T.
to
Yes.
the midpoint
Uh-huh.
formula, then you'll get that.
Okay, yeah. So, yeah, the midpoint formula. To use the midpoint formula, we have to know what these order pairs are, right? R and P. So you have to kind of work backwards, isn't that right? Because we said M is A comma B, right? You understand what I'm trying to say? Also, well, think about this. If they call this M A comma B, right? What if I were to draw a vertical line through M? Look at where this vertical line hits the x-axis. Where would it hit? A, right? So Brianna, if it hits at A, guess what? It's going to be the midpoint of this segment, right? Remember that was one of the theorems we learned. If you were to draw A, right? Line that is parallel to one of the side, okay? Oops, okay, zoomed in too much. If I were to draw a line that is parallel to one of the side, right? What do you know about this line that's parallel to this that goes to the midpoint of this one of the side? It's going to go to the midpoint of the other, right? So if this distance is A, guess what? The other is also A, so it's got to be twice as A. We could do the same thing. We could draw a horizontal line through M, right? M is the midpoint of one of the side of the triangle. Guess what? It's going to go through the midpoint of the other side, right? If this is parallel to the other. So if this is the distance from O, if this is B right here, O to R is going to be twice as much. Does that make sense?
Yeah.
Okay, now, could they have called this P A comma 0?
Yeah.
Yes, they could have. And could they have called R O comma B?
Yeah.
And what would this be then?
A over
Yeah, A over 2, because you add them together divided by 2, right? And B over 2. Would that be a good idea to actually? Why is that not? Why is that? Yeah, because it makes it more, yeah, just make it simple as possible. You don't want to deal with fractions if you could avoid it, right? You could avoid this by making this 2A comma 0 and then 0 comma 2B. Does that make sense?
Yes.
All right. So let's then find the distance of OM and MR or MP, because we know that MR and MP are equal, right, the distance. So first, let's find the distance of OM. What are you going to do? What's the distance formula for 2 points? Square root of what? X of 2 minus X of 1 squared plus Y sub 2 minus Y sub 1 squared. Okay, go ahead, everybody try. Tell me the distance of OM and also find either MR or MP. It's up to you. Go ahead, everybody try. I'll wait. Find the distance of OM first and then find either MR or MP. See if they're truly equidistant. Okay, go ahead, everybody try. I'll wait. Okay, who can tell me what the distance of OM is? How about Ivera? I'm using, what's the order pair for origin? 0, 0, right? And the order pair for M is A comma B. So if you do X of 2 minus X of 1, what do you get? Okay, so it should be what? Let's just do it together. Using the distance formula is square root of X of 2 minus X of 1 squared plus Y sub 2 minus Y sub. So it's going to be A minus 0 squared, which is what? A squared plus, what's B minus 0? And then the whole thing has to be in square roots. What's the answer? Square root of. You add them together. Yeah. Okay. Does this make sense? Don't we get square root of A squared minus B and plus B squared? You just follow the distance formula, right? Yes. Who can tell me who's got the distance of? How about MP? Who's got the distance of MP? Okay, Andrew. Yeah, it's the same thing. Okay, it better be, right? Because you do A minus, they did A minus 2A, same thing, right? A minus 2A, you get negative A squared plus B minus 0 is, right, B squared. So square root of it, get the same thing. Did anybody find MP, MR? Yeah, what did you get?
Same thing
Exactly same thing, right? So, but they don't do that because they say m is the midpoint. So why find the other one? You could, but you could still find it. It doesn't matter. So that's it. That's how you prove this theorem. Isn't this easy? You do this algebraically this way. You show that.
You don't need to use it.
Yeah. So you say So you say because we have shown that. So therefore we showed all three distance are same, guys. You can use hence if you like. Okay. Or you could say therefore. Okay. So therefore you get what? You have proved it. You have proven the theorem. It's equidistant. Yeah, so tomorrow it'll be like this. But you're going to use coordinate proof. Not today. You're going to use coordinate proof. But like I said, guys, today we're going to show you how to organize. This is the part. You see how we label these things like this? That's what we will be working on. Does that make sense? All right, let's move on to then the next one. Okay. Can somebody read this for us? How about Samantha?
Notice that 2a and 2b are convenient choices for coordinates since they lead to expressions that do not contain fractions for the coordinates of n.
Do you see? We just talked about this, right? If you could avoid it, you don't want any fractions when you're doing these. Okay? It's just much easier that way. All right? Now, can you keep reading? If you have.
If you have a right triangle, such as triangle POR on page 556, the most convenient place to put the x-axis and y-axis is usually along the lengths of the triangle.
Good. So that's the triangle that we just looked at, right? If you have a right triangle, it makes sense to have one of the leg on the x-axis and the other on the y-axis and then draw the hypotenuse, right? Does that make sense? But are you going to always have to do some things for right triangles, prove things? No, you can have triangles that are not right triangle. It could be regular any triangle, it could be isosceles, it could be rectangles, right? Squares, right? So many different. All right, okay, hold on. Okay, so Austin, can you read this for us? If.
You have a right triangle.
Hold on, right here. If a triangle is not.
If a triangle is not a right triangle,
Mm-hmm.
the most convenient is to place the axes are shown below.
Mm-hmm.
This actually is the axis maximize the number of times zero. Is the coordinate on the z.
So we want to maximize what number of zeros on the coordinates. Okay, and it makes sense. Why? Do you have to do it this way? Yeah, no, but it's the easiest way, right? It's the most simplest, right? You want it, right? Make it as simple as possible. I mean, sometimes you can avoid it. You can't make everything 0, 0, right? But you want to maximize the number of zeros, right? So that it's easier for you to do these coordinate proofs. Does that make sense? And you want to use, can I use like 10 variables if I want to?
Yeah.
Yeah, but is that the best way? You want to use what? Yeah, fewest, right? You want to use, right? You don't want to use it, right? You want to use the smallest amount of variables you can possible, right? Yeah, minimum number of variables you can. Okay, so you want to use maximum number of zeros, but you want to use minimum number of variables. Otherwise, it's going to get really difficult, right? Then it should. Okay, so let's move on to the notes now. Next part. Here we go. So let's look at some of the examples here. Look, if they ask you to prove, right, something about a regular triangle, right? Look, this is one of the way of doing it. You see how I have, how many zeros am I using for these? Yeah, I'm maximizing number of zeros. Could I use 4 zeros? No, you can't just force it, right? But this is a maximum number of zeros you could use. I call one of them 0b, the other c comma 0, and then a comma 0 for the other. Is this the only way to do it? No. Okay, you could actually do it this way if you want. Make everything in first quadrant, right? As you can see, one of the point is, or at the origin. That's kind of nice because that point is 0, 0, right? And of course, this has to be d comma e, right? And then this is f comma 0. We know this is going to be 0 because it's on the x-axis, right? As you can see in both of these, we're maximizing number of zeros, right? How many zeros are we using for the coordinates in this one? Yeah, 3, because the origin, what is the order pair? 0, 0, right? And then, how many variables are we using here? 3. What about on the left? 3. So it really doesn't matter which one you like, which one you use. Right? It should be pretty much similar. Does that make sense? All right. Do they always give you a triangle?
No.
No. Okay. By the way, do you see how both of these represents every single triangle you could possibly draw? Right? Because A, B, C could be any numbers you want. Does that make sense? So do you see how it represents every triangle? Because then if you could prove something on this, right, it means you're proving it for every triangle. Okay. All right, so next, let's talk about some isosceles triangle. Okay, here we go. Okay, here we go. I have an isosceles triangle. As you can see, I have D as 2a comma 0. And We did that on purpose. Now, if I wanted to, I could have done a comma 0, and you'll see why I did it as 2 comma 0. Okay? If I did label D as 2a comma 0, what would then order pair for C be? Okay, I want you to think about it as a group. What would you name C? What would the order pair for C be? Okay, think about it, guys. Everybody try. Oh wait. You see why I call this 2a comma 0. Okay, there's a reason why we did this 2a comma 0, not a comma 0. Think about it. Go ahead. All right, Jason. What would you label C as? AB. How many people agree with Jason? Okay, very good. It's going to be AB, isn't it? Why should this be A comma B? Because, by the way, it's an isosceles triangle. It's like this, right? So why should it be AB here? You could explain? You better. Exactly. If I were to draw an altitude, right, right there, how long is this distance?
Equal to A.
Yeah, it's going to be A, right? Because this whole thing represents 2A, right? So therefore, one of them has to be A, the other has to be A. Yes? And if that's A, well, to get to that point C, you have to go to the right distance, A, and go up. Now, this B could be any, right? It could be any height that you like, right? As long as you go to the right A distance, right? Because it's an isosceles triangle. Do you get that? That's what you want to do. Another way of doing it is this way. You could have the vertex on the y-axis, right? And then sort of kind of symmetrical like this. Okay, so if I call this point G the A comma 0, E is 0 comma B, what would the point F be? Go ahead, everybody think about it. Again, it's an isosceles triangle. Okay, what do you think? Go ahead, everybody think about it. I'll wait. Okay, Brianna, what did you guys come up with? What would the order pair for F be? Negative A 0. How many people agree with Brianna? It's correct. It is negative A 0. And why is that? Who could explain? How about Brandon? Why is it negative A 0?
Because the 2 sides are equal.
Yeah. Basically, this O is going to be the what? O will be the, in terms of FG, what's O? Midpoint. So this is equal to this, right? So the distance from here to this A. How come we don't put A comma 0? Why is it negative A comma 0? Yeah, it's on the negative side. It's actually, I'm not talking about the actual distance. I'm talking about the actual coordinate, right? The order pair. So if you ever get confused, guys, here's a nice way to do this. Just actually, instead of writing A comma 0, write like 3 comma 0. If this point is 3 comma 0, what must be this? Negative 3 0. Does that make sense? Yeah, that's one of the ways to help you understand, right? If you ever get confused. Like put in some numbers, right? Do an example. I know that this will be a particular example. This will not represent every right triangle. I mean, every isosceles triangle, right? But it's okay. Just do an example, and then you could use the variable. Okay. All right. Let's move on to the next example. Okay. This time, you don't always have to have triangles. This time they give you a rectangle. Okay. So what would the okay? If I call J A comma 0, that's kind of obvious, right? Because it's going to be on the x-axis, J, and then H is on the y-axis, is 0 comma B. What would the order pair for K be? This is pretty straightforward. Go ahead, everybody think about it. Go ahead, I'll wait. Think about it. All right, so how about Eric? What did your group come up with? AB. How many people agree with Eric's group? Correct, it is AB. Who could explain why it's AB? Okay, hold on. How about Amy? Why is this A comma B? K would have in terms of, let's look at the y coordinate of K. The y coordinate of K has to have the same y as what? H. Why? Because it's a horizontal line, right? HK is a horizontal line, right guys? What do you know about a horizontal line? Although they share the y coordinate, don't they? They have the same y coordinate. What about KJ? Isn't that a vertical line? They have the same x coordinate. That's why it's A comma B. Right? All right. Okay, let's look at, this is a parallelogram. If n is A comma 0 and m is B comma C, as you can see, m has nothing to do with this A, right? So it's B comma C. What would the order pair for P be? How about, everybody think about it. I'll wait. Go ahead, think about it. Now, if you get stuck, put some numbers in them, okay? That really helps. Go ahead, think about it. Okay, so first of all, before we actually do this with variables, let me show you how easy it is if we do it with some numbers. Let me call this A 7 comma 0. If I call that A 7 comma 0, let's call this B and C could be any numbers. How about, by the way, when I say any number, I probably don't want to put like Yeah, it's gotta be. If this is a picture, I would do lower than 7. How about like 2, 5? Okay. Now, if that's 2, 5, and this is 7, 0, what would P be? Who could tell me? How about? Let's see. Grace Kim, what do you think? 9, 5. How do you know this?
It's like A plus B.
Yeah, because look, if I were to draw a vertical line through M right here, what would this point be? This would be at B, 0, would it not? Because in order to get to M, don't you have to go to the right unit, right? You have to go to the right B unit and go up C. So isn't this distance B? Right? If that's B, right? In this case, what is that? It's not B. In this case, it's 2. In this case, it wouldn't just be 2. Right? So, well, think about this. To get to P, if you go up here, this point right here is A, 5, right? And 7, 5. Wouldn't this be 7, 5? Because this is 7, 0, right? If I were to go up straight like this, wouldn't this be 7, 5? How many units do you have to go to the right since it's a parallelogram? 2 units to the right. So don't you have end up at 9, 5? Do you get the idea? Okay, if you don't get this, go ahead. I'll go ahead, talk to your neighbors. See if you can understand. Go ahead, I'll wait. All right, so does this make sense as to why this is 9, 5? Yeah, because if this is 7, 0, go straight up. Isn't that 7, 5? Well, you have to go to the 2 units to the right. Okay, so if that's true, what would it be in terms of ABC? Okay, who could tell me? How about Nicholas? What would the order pair P be? Yeah, A plus B, C. Isn't that how we got 9? 7 plus 2, A plus B, right? 5, which is C. Right? So if you ever get confused, right, just like use some numbers, plug it in, and figure it out. Does that make sense? Okay, let's move on to the other ones. Here we go. All right, take a look at this. Now we have a trapezoid. So if you have to prove something about trapezoid, this will represent every trapezoid. Okay, you can think of. So if I'm going to call this R A0 again, it's kind of similar. Now this S has nothing to do with, there's no relation to this A, so it's going to be B, C, right? What about T? What would T be? Now imagine, think about, this is not an isosceles trapezoid. People were thinking about an isosceles trapezoid. This is not an isosceles trapezoid. This is regular. It could be. It's a trapezoid. Okay. So what would the order pair for T be? Again, if you're confused, plug in some values of numbers there. Okay. Go ahead. I'll wait. Go ahead. Everybody think about it. All right. So who could tell me what the order pair for T is? How about Esther over here? What do you think? DC. How many people agree with Esther's group? You guys are correct. It is DC. Why is it DC? Does D? Okay. So first of all, listen, guys. We know that C, the y-coordinate of this point T has to be C because, you know, it has to have the same y-coordinate as S, right? Because it's a horizontal line, right? Why is this D? Why can't we use ABC to represent this D here? Yeah, Nicholas?
Because the x value of the x coordinate of T is completely unrelated to any.
It's not. Yeah, it's not related at all to ABC, is it? It doesn't matter where ABC is, right? Does that make sense? Okay, let's do this one now. Now I have an isosceles trapezoid. Okay, if I have an isosceles trapezoid, what would the order pair for W be? Go ahead, everybody think about it. Oh wait, what do you think? So how would you do this? Let's actually put some like order pairs. Okay, how about I call it 10, 0. BC, let's call it 3, how about 6? Okay, then what about W? It's gonna be something, 6. That's obvious. What would the x coordinate be on this? How about, hold on, how about Nicole, what do you think? 7, you're right. Why is it 7? Yeah, because 10 minus 3, if you think about this, if you were to draw this one right here, if the distance from here to here is 10, what would this distance be? Same as this distance, right? Which is 3 right here. This is 3. So if this is 10, you got to subtract 3 from it. So in terms of ABC, what would this be? How about Chris? What would you put down as the order pair? Yeah, it is A minus B, C. Easy enough? Does this make sense? Any questions? All right, let's do some examples then. Okay. Here's example 1. What would the order pair for this isosceles triangle be if this one right here on the bottom is 2a comma 0? Yeah, I want you to write it down. Go ahead. Oh wait, think about it. All right, so who can tell me what this is? How about Naomi? What did you guys come up with? AB. How many people agree with Naomi's group? You guys are correct. It is AB, right? Because this down here is 2a. You know, it's an isosceles triangle, right? This is halfway. If you were to draw a vertical line through this, it'll hit at A, right? Because it's twice as long. All right, then what about this? Go ahead. We have an isosceles trapezoid. Tell me the order pair for the top left point. Go ahead, everybody think about it. I'll wait. How about, first of all, guys, listen. Here we go. Kevin. We know that both, it's a trapezoid, so you know that the two bases are parallel, right? Two bases are parallel. So the y-coordinate of this point has to be same as y-coordinate of the other on the right side. It's got to be what? F. What about for the x-coordinate? If it's an isosceles trapezoid, and this down here is negative 3e, 0, 3e, 0, this has got to be negative 2e, right? It's symmetrical if you think about it, right? The distance from here to here is 2e. It's got to be 2e on the other side because right here is 3e, here to here is negative 3e. Yes? All right. What about this now? What if I have this rectangle? You have a rectangle. Tell me the order pair. Yes. So you get, here is 2j as a y-coordinate. This is 3j, 0, negative 3j, 0, something 2j, and then something, something. Okay, what do you think? Everybody think about it. All right, so first of all, I know the y-coordinate of the top right, top left. What would the y-coordinate of the top right be? Top left be?
3j.
No, it's 2j, same as the height of this other point, right?
Oh, 2j.
Okay, now what about the x-coordinate of this? It's got to be 3j because it's a vertical line, right? Vertical lines have same x-coordinates, so 3j. Okay, what about this one then? Easy enough? Okay, can you do something like this for your homework tonight? All right, good.